y double prime plus, oh, minus 4y prime plus 4y equals 2e to the 2x plus 4x minus 12. And our solution is c1e to the 2x plus c2x e to the 2x plus x squared e to the 2x plus x minus 2. And we want to show that this is a solution, right? The first thing it says is show that it's a solution on the indicated interval. The advantage is I can do the interval part before I do anything else. These functions, e to the 2x, x e to the 2x, x squared e to the 2x, and x, and these numbers are constant, and these functions, they're defined for all real values, right? That means this is going to go from minus infinity to infinity. Here's the hard part. Take the first and second derivative. You don't actually have to work out where this solution came from. You just have to show me that this is a solution. So I need to show that when I take this y prime and this y prime and this y double prime and put it back in, this is what I get. The derivative of e to the 2x is 2e to the 2x. The c1 just stays along for the ride. When I do the c2 part, though, there's a product rule there. So I get e to the 2x plus 2x e to the 2x. When I do this, there's a product rule. So I get 2x e to the 2x plus 2x squared e to the 2x. And then I get a plus 1. And the derivative of minus 2 is 0. Talk to me, Jalen. Yeah, I got to do the second derivative, and I got to plug it all in and make sure it all balances out. It ain't short, but it is direct. Y double prime is 4c1 e to the 2x plus c2 times, all right, I'm going to get another product rule in here, 2e to the 2x plus 2e to the 2x plus 4x e to the 2x plus the derivative here is going to be another product rule, 2e to the 2x plus 4x e to the 2x. Same thing here. I get 4x e to the 2x plus 4x squared e to the 2x plus 0. It is probably in my best interest at this point to gather my like terms, just to make crap smaller. But I'm going to take 1y double prime minus 4y prime plus 4y. And a lot of things should cancel. All the C1, C2 stuff should cancel. And then I should be left with 2e to the 2x plus 4x minus 12. If I'm not, I have to sum up somewhere along the line. Jalen, does that make sense? All right. Yeah, when it says verify that this is a solution, that's all you have to do is take it and plug stuff in. So somebody hit me with the next question. Yes, ma'am.
General question for 4.2. Some of my answers had confidence and some of them didn't. So I was just wondering, should we like assume that, like, without laws of generality, that C is one for some of them, or like, are there supposed to be constants in our answers?
So when you do the formula with the integration in it, right? You can assume that the constants you get are 1 and 0 respectively. So on page 133, we have this formula for the reduction of order, right? And it says right here, by choosing the first constant of integration, the one that comes from up here, to be 1, and the second one to be 0, this becomes this nice easy version of the formula. So I should not end up with an integral, a constant when I do this integral. And I should not end up with a constant when I do this integral. Pick one that you did that you think you have a constant in. Let's look at something similar to it.
6.
Okay, 5 is very similar. It's just got a 1 though instead of a 5, right? So let's do y double prime minus y equals 0. And we know that y1 is hyperbolic cosine of x. I don't often write answers in hyperbolic functions because we kind of skipped them in Calc 1. But hyperbolic functions are really related to ease. So the hyperbolic cosine is e to the x plus e to the minus x over 2. If you would rather work with it like that, that's fine, but you can work with it just as hyperbolic cosine. So y2 is y1 times the integral of e to the negative integral p of x dx over y1 squared dx. Right? Okay. But what's p of x in this problem? Y negative 1. Because it's the thing that goes with the y prime. How many y primes do we have? Right. So p of x is 0. What's the integral of 0? A constant. 1. I might as well just call it 1. So we're going to get e to the, wait a minute, no, integral of 0 is 0 plus c, right? We said we were going to let the plus c be 0. So we're going to leave that as e to the 0. What's e to the 0? Now I'm in a little bit of trouble. Because now I need to think about what are the derivatives and antiderivatives for hyperbolic functions. And we know those so well, don't we? Chapter 3, section 11 in the calc book, which I know in my calc class and in McNabb's calc class and in Burns's calc class, we keep skipping 1 over cosine. What's the other trig function for 1 over cosine? Oh, then I can stop here. Okay, yep. Okay, just for the record though, 1 over cosine is secant. This is secant squared. What's the integral of secant squared? Tangent. And tangent is sine over cosine. So I have cosine times sine over cosine, I get sine. The other answer, when you're all said and done, in this case, is hyperbolic sine of x.
Zero, I had C, that's where my C was.
But I can make the assumption that that c is a zero in this problem. The integral constant up here should always be a zero. The added integral constant should be a zero in this entire setup. So I think in the one you were doing, there was like an e to the 5x
Yeah.
for number 6. So I think we should just end up with an x. X e to the 5x, I think. More questions? Or 361. I hope so. Find a differential equation. 59. Find a differential equation whose solution is given. Okay. I like this one because I start with a solution and then I have to find the equation, right? So what's the solution in this case? It's C1 times e to the negative x cosine x plus C2 e to the negative x sine x, right? Okay. It's not on the screen. You can't see squat. All right, hang on a second. When I see e's and cosines and e's and sines, I know that this came from a complex number, right? So I know that this came from my roots being a plus or minus bi, where a is the number that goes up here and b is the number that goes there. So in this case, they're both 1 and negative 1. So I know this should be minus 1 plus or minus I, 1i. With me so far? If those are the roots, then the auxiliary equation must look like r minus negative 1 plus I times r minus negative 1 minus I equals 0. If these are our roots, then it must have been r minus root and r minus root. But wait a second. Multiply this out. Give me a quadratic. I get r squared minus negative 1 plus I times r minus negative 1 minus I times r plus negative 1 plus I times negative 1 minus I. I just FOILed it out, right? What's going to happen in here? Well, a lot of things are going to cancel. I got an r squared, and then I have a plus r and a minus ir. And then here, I have another plus r, but this time I have plus IR. Those are going to cancel. And when I multiply this out, I get 1 minus I plus I minus I squared. What's I squared? Which makes this 1. So these cancel. This becomes a plus 1, and I get R squared plus 2R plus 2 equals 0. Say again? Good, good, good. Hoorah. Here's the best one. If that's the auxiliary equation, then the differential equation is y double prime plus 2y prime plus 2y equals 0. Once I have the equation in R, I can get the differential equation. The whole purpose of these problems is for you to go, oh, wait, those roots must come from this sort of setting. Those solution pieces must come from these sorts of roots. Now I can go through and figure out what the equation is. How often do we have to work backwards from the roots, from the solution to find the equation? Very rarely. Complex numbers are my friend. More questions? Mia, you had your hand up for something else too.
Going back to,
Yes.
can you do number 3? Can you do it with like the procedure?
Sure. So it says y double prime plus 16y equals 0, and y1 is cosine x, right?
Correct.
Oh, yes, cosine 4x. Good catch. Y double prime plus 16y equals 0. Y1 is cosine 4x. Okay. I'm going to make the assumption that y2 should be some function of x times cosine of 4x. I need the first and second derivatives of that. So, product rule here. U prime times cosine 4x. Derivative cosine is, but I get a 4 from the chain rule, so I get minus 4 sine 4x times u. Second derivative. U double prime cosine 4x minus 4 sine 4x times u prime. Then I do this part and I get minus 4 sine 4x u prime. Derivative sine is cosine, 4 cosine 4x. Wait, I'm going to get another 4, so that won't be a minus 4. That'll be a plus 16 times u. Minus a minus. Oh, no. No, it's a minus 16. Good catch. Because it's just the derivative of sine is cosine. There's no extra minus sign. It won't work too many different ways in my head. I'm thinking about e, the second derivative, the negative should come out again. There's no negative inside. Sign error, minus 1 to me. Okay, let's plug all this garbage in to this equation. But notice I can gather a like term here before I do that. U double prime cosine 4x minus 8 sine 4x u prime minus 16 cosine 4x u. And it says y double prime plus 16y equals 0. This is y double prime. So that's u double prime cosine 4x minus 8 sine 4x u prime minus 16 cosine 4x u plus 16 times y, which is u cosine 4x. Hey, look, this and this cancel out exactly, don't they? Which means the result is u double prime cosine 4x minus 8 sine 4x u prime is supposed to be equal to 0. This is a first order equation if we reduce the order. I'm going to write this where v is equal to u prime. So this is now v prime cosine 4x minus 8 sine 4x v equals 0. Blah, right? This is a first order equation. Either it's separable or linear or exact. Which way do you want to try and do it? Okay, if it's linear, then I should have the v prime all alone, right? So I'm going to divide by cosine of 4x. V prime minus 8 tangent 4x v equals 0. So this is p of x, and I need my integrating factor. My integrating factor, mu of x, is e to the integral p of x dx. So I need e to the integral of negative 8 tangent of x. Mommy. It's not wrong. It's just ugly. It's the integral of tangent. That's the derivative. Chapter 5, Section 5, substitution. I write tangent as sine of x over cosine of x. And then I do a u sub. The derivative of cosine is sine. So this becomes ln of cosine of x. I'm sorry, derivative of cosine is minus sine. I get negative ln cosine x. That goes up here. Talk to me. Yes, 4x, which means I'm going to get 4x, 4x, 4x. I'm going to get an extra factor of 4 there, right? I don't have that 4, so I'm going to get a 1/4 there. Okay. Wait a minute, there's an 8 there. What's 8 times a fourth? That was not supposed to stump the room. Right, it's just a 2. So this becomes e to the 2 ln cosine 4x. How do I simplify that? And then the e and the ln will cancel each other out. Wonderful, beautiful, perfect. That means that when I go to do this, I multiply by this everywhere, and I have cosine squared 4x v prime minus 8 tangent 4x cosine squared 4x v equals 0. Hey, wait a minute. Tangent is sine over cosine, isn't it? That means this is going to be 8 sine 4x over cosine 4x times cosine squared 4x, which is going to give me 8 sine 4x cosine 4x v cosine squared 4x v prime. What's the derivative of cosine squared stuff? Chain rule, right? 2 cosine 4x times the derivative of cosine. Derivative of cosine, which is sine. And then a 4, right? 2 times 4, cosine, sine. This is the derivative of that. It worked. Son of a bitch. Cosine squared 4x v prime equals 0. That's a product rule. Son of a. So now I can integrate. And the integral is cosine squared 4x v equals constant. Right? So that means that v is constant over cosine squared 4x. That's v, right? But v was, scoot back up there, v is u prime. So I need to integrate again. To get u, I take the integral of v. Before you run screaming from the hills, what's 1 over cosine? And now, Jalen, that's secant squared. What's the integral of secant squared? Ah, you said the derivative tangent was secant squared. So this must be c tangent 4x. Oh, what did I forget? Well, I forgot something else too. There is another c, the 1/4. But now I can play the game. Constant over 4 is just another constant, right? I might as well let this be 1 and this be 0. Why? Because where does u come into the game? y2 is u times cosine 4x. So now I can say that y2 is tangent 4x times cosine 4x. And what happens when I simplify that? I just get sine of 4x. So you see, I did it with the method rather than the formula. It took longer, got exactly the right result. By the way, I have not done this problem until right now. This is my first time ever doing this problem. How do I know that's the right answer? I promise, there is a 100% chance this is the right answer. What was the original differential equation we were solving? Which means that's r squared plus 16 equals 0, or r squared equals negative 16. I'm going to get complex numbers, and that means I'm going to get a sine and a cosine. As a matter of fact, what I get is r equals 0 plus or minus 4i. So the solutions are C1 e to the 0 cosine 4x and C2 e to the 0 sine 4x. They gave us this one and we found this one. But technically that part is section 4.3. And we were in section 4.2, so we didn't know that that was going to be the case. Hey, Mia, which one's easier? The formula or the substitution? See, it's real toss-up, isn't it? Do you like doing the integrals within the integrals, or do you like working, trying to figure out which integral you got to do on your own? It really is a toss-up as to which one is the easier one to do on any given day. If you're comfortable doing the integrals and doing the reduction of order part, I work from the don't work from the formula. I work through the method instead. That's because I can't memorize formulas worth shit. But that's me. And you guys get a formula sheet. So if you wrote it down, what the hell? I just had a horrible flashback. The last time I taught this section that really sticks in my head, I was over in Lynch in a classroom that doesn't exist anymore. And the nightly business report was doing an article on college football. And they had interviewed some big universities. And they wanted to interview some small universities that had just started a football program, like Seton Hill. And so they wandered around taking pictures and doing film all over campus. And they said, we got shots of students in labs, we got shots of students in lounges, we got shots of students in group work. We didn't get anybody actually teaching. And they came into my classroom and said, can we film you for the nightly business report? And so I am standing at a chalkboard doing a problem like this, jumping up and down about integrals, being really happy with a microphone and a TV camera. I think I was on camera for about 3 seconds in the final report. I put it in my 10-year portfolio. Look, they put me on TV.
Say it was.
The nightly business report. I think it'll be like 2006, 2007, 2008. I don't know. When did we found the football team? There you go. It was a long time ago. I'm not even wearing a tie in that picture. More questions? There. Nightly business report. Part 2 small time ball. That's it. Hang on a second. 18 years ago. There you go. So it was 2007. It's not that long a piece. Yeah, they were here. They interviewed a bunch of people, yeah. The president, the head coach, they got film of everybody, yeah. Anyhow. Now I get to say with a straight face, y'all were 7. 6, 5.
No 6.
I was gonna say in 07.
Oh, wow, off it field looks like 6.
All right, ask me more questions about Tip EQ before we go off on a football team.
He'll check right, kick it.
And no, I doubt it. He would have been what? 10?
Six.
In which
Four,
that
one.
4-1. Uh-huh.
What do you mean by like, well, tasking by inspection? So you just assume that
Give me any function at all that will satisfy that differential equation.
so instead of the particulars in like y,
Mhm.
a,
Yeah,
that
I don't even have to work through it. If I just pick a constant, right? A constant has its first derivative be 0 and its second derivative be 0, right? So I just want 2a to be equal to 10. I'm done. That's why it says by inspection, because you really don't have to do a lot of work to get to this particular answer. Did you find my picture in this thing? Is that what you're looking at? Yeah, there I am, right? V of t times yt, there it is, huh?
they got action shot right there.
Yep. Let's see. The giant double board, and there I am writing it. It's this stuff.
When did you start this? Suspended?
Like 2 or
No.
No. He would have been, he would only have been like 12, 14, 30. Had more hair. It said it was 2007?
Oh my God, he looks so young.
Squeak.
His skin looks tight.
Oh, that's funny. There's who was in the class. Fall of 2007.
I'm guaranteed my. Where you train?
That's why I put it away real quick. Let's see. Trisha Wollslegel is a middle school teacher in West Virginia. Justin Ryan works at Johns Hopkins as operations research. He just got married a couple of days ago. James Mills is the son of Sherry Mills, who works in the registrar's office. So yeah, yeah. That's who's in the class. So that picture of the rest of them, that's them. And Noah, about 3 years ago, when I couldn't wear a belt anymore because of my hip and the neuralgia paresthetica that came into my thigh, that's when I started wearing suspenders on a regular basis.
I like this.
Yeah, I was gonna say, it keeps me from limping all day long. That's the best part. Pinch nerve in my hip means I want to run like this.
Oh, that's fun.
I'd walk worse than Cody here. And that would be bad. Anyhow, I got 10 more minutes of Diffie-Q with your name on it. What do you want to ask me? You're not going to hear my voice. They'll be talking over me.
Press 21, 43.
21 on 4-2. So this one says first find the second solution and then find a particular solution, right? So 21, y double prime minus 3y prime plus 2y plus 2y plus 5e to the 3x. And they tell me y1 is e to the x. So first thing I have to do is deal with a homogeneous version. Do you want to use the formula or do you want to use the method to get there? Okay, so I'm going to say y double prime minus 3y prime plus 2y equals 0. And y2 is going to be u e to the x. So that means y2 prime is u prime e to the x plus u e to the x. y2 double prime, u double prime e to the x plus 2u prime e to the x plus u e to the x. I get two of them because I get one when I take the derivative of the e to the x here, and I get one when I take the derivative of the u there. Plug that in up here. U double prime e to the x, 2u prime e to the x, u e to the x minus 3 times the quantity, u prime e to the x plus u e to the x plus 2u e to the x should be 0. Well, I've got one u e to the x, I've got two of them, and then I've got minus 3 of them, so they're going to be gone. So that means I get u double prime e to the x plus 2u prime e to the x minus 3u prime e to the x equals 0. U double prime minus u prime equals 0. E to the x is never 0, so I can divide it out. Oh, wait a minute. So that means that v prime minus v equals 0. I know the solution to this. E to the x minus e to the x is 0, but we'll work through it. This is dv dx equals v. So I get dv over v equals dx. Integrate ln v is the integral of 1 x. So v is e to the x. That means that u is also e to the x, because the integral of e to the x is e to the x. And that means that y2 is e to the x times e to the x, or e to the 2x. So far, so good? So now I have to find the particular solution part, right? So I know that I want y double prime minus 3y prime plus 2y to be equal to 5e to the 3x. And I know that y should be c1 e to the x plus C2 e to the 2x plus whatever my particular solution part is, right? So let's think about the e to the 3x bit, because I got e to the x, I got e to the 2x, I don't have anything with e to the 3x, right? So we have to figure out how we're going to come up with what this particular solution is. I'm flipping my way back to the original. To section 4.1, where all the theory was in, and it says non-homogeneous equations. The thing that I'm missing is the e to the 3x part. So I got to figure out where that e to the 3x is going to come from. It's got to come from some other e to the 3x's, right? Yes? If I plug that in here, it doesn't quite work, does it? I get 9 of them minus 9 of them plus 2 of them. That's not 5 of them. But maybe if I added some sort of a constant here, right? Multiplied it on. What if I did a e to the 3x, right? Then I'd have 3a e to the 3x, and I'd have 9a e to the 3x. And if I put those in, I'd have 9a e to the 3x minus 9a e to the 3x plus 2a e to the 3x was 5e to the 3x. What's the value of a that makes that work? Aha! So I think yp should be 5 over 2 e to the 3x. I like this idea. I want to talk more about this idea in particular, because finding particular solutions is weird. We had to guess and hope, right? There's got to be better methods on that. But that's what we'll talk about next week.
Well, you do it every time
Well, but this is exactly the right lead-in to that question. That's exactly where we're going. How do I solve and find out the non-homogeneous part? And I like this idea for exactly this reason. It says, oh, well, I think I should have this extra bit. How do I get it to fit? We'll talk about that more on Wednesday. Because you don't get to see me until then. Enjoy your fall break. I will see you when we get back on Wednesday.